So today I'm going to give you the final, basically highlights of this project. I'll give you a little bit of a introduction and timeline. I believe it was 3 years ago that working with a focus group with Kevin and Bruce and Amy and others who were interested in safety, and this was one of the priorities of the agency in terms of having a better understanding of managing speeds in work zones. And so through 2 years of data collection in the previous summer construction season as well as the year before, we tried out a number of different things and we learned a lot of different lessons, not just on speed management, but on the various data collection and the tools that would be appropriate for this kind of project. So I'm going to be talking to you guys a little bit about that today. So we'll start out with just a very brief background, the specific project objectives, go through the methodologies, and some highlights of the results. I'm actually not going to do all of the results. I'm going to highlight the ones that we have the most confidence in, as well as the ones that might be the most used policy-wise. So as far as work zone crashes is concerned, they've actually been fluctuating a little bit, but in the last 5 years, they hovered around 600 fatalities a year. In Vermont, we're extremely lucky in that we don't have too many of them, so which is why I'm kind of really looking at the national data. It's interesting that in the last 10 years of data that were basically available, this is an 8-year period from 2002 to 2010, work zone fatalities across the country has basically been halved. At the same time, the VMT has increased just marginally, or in some cases basically stuck around the same. So it's good to kind of see that although there's not a direct correlation between the amount of travel and the exposure that you would expect, if we assume that they are similar, that we are doing something right, or at least the focus that the country has on work zones is paying off to a certain degree. And then when you're comparing work zone fatalities to general fatalities on our roads, general fatalities has also been decreasing, but not at the same rate as work zone fatalities have. So the caveat is that work zone fatalities really does depend on the amount of construction activities, which does fluctuate a little bit, but and it does not necessarily correlate with the amount of travel, but it's still one of the indicators that we kind of look at. But still, we're nowhere near eliminating injuries as well as fatalities, so it's still a good focus to look at. Given the data that's available, what we know about work zone crashes is that speeding is a contributing factor in about a third of them. Hi, Deb. No problem. Please join us. So speeding is a contributing factor for at least a third of these crashes, and it's quite an important thing when you're thinking about restricted or constricted spaces, a lot of merging and movements, a lot of speed changes. And so if we're able to better manage the speed through these work zones, the theory is that we should be able to better prevent crashes, injuries, and fatalities. So specifically for this project, we looked at really the effectiveness of different types of tools that we can use to manage speed and to assess the ways that these tools are really impacting the compliance of the drivers with the work zone speed limits. We looked at a number of different management tools. Very specifically, we were interested in how uniformed traffic officers, which is really a passive enforcement where you have blue light vehicles sitting somewhere within the work zone and there's not usually active police enforcement. And then the other ones that we looked at is what happens if there is a case where there is active police targeted enforcement of the area. Something that is more mechanical would be our radar speed feedback signs. These are the displays where each incoming vehicles get a feedback of how fast they're going right next to another sign that basically says what the speed limit is. And then we also tried a combination of the UTO with these RSFS to see if there's any compounding effects in which that these devices, when used together, will have. Knowing that a work zone is not static, there are different periods in which you might want to have extra speed management because you're moving things around or because there's extra activity. So there might be different cases in which these tools would be applicable. And what I don't get into in this research is the cost of these, but it should be straightforward that any time you have a person, like a police officer, either a UTO case or a active enforcement, that would cost more than having a sign that is out there. So as far as the methodology is concerned, we went out in 2012 and 2013. I worked with Bruce and Amy and others in terms of looking at sites that were potentially useful for this project. Good thing most of you are from Vermont, so you don't need to read the towns to see where they are. But basically, we looked at a number of sites on the two freeways that we have. Brattleboro down south, where they had this bridge project, and then this other bridge painting list of projects up in St. Albans. Those were our freeways one. And then we had a whole bunch of two-lane highway ones that we also considered. Throughout the state, we wanted to get a feel of the different characteristics of the state. We considered 10 sites, and in the first year in 2012, we actually went out and tried different sites. And when I talk about how we collected the speed, I'll explain a little bit more of why we didn't use some of these sites. But basically, we ended up collecting data in 3 sites in 2012. We did it in Richmond, where they were fixing up the Route 2 bridge. Addison, New Haven, where they were repaving Route 17. And then Brattleboro, that bridge project. And then 3 projects in 2013, basically 3 in a row in terms of the bridges in St. Albans. Now, for the focus of this presentation, I'm going to specifically talk about the interstates. We do have the Richmond and Addison data, and that's in the report. But what we've found, especially given the device that we were using for collecting speeds, I have a much higher confidence in terms of the data that we have for the highway, for the divided freeway, as opposed to the 2-lane roadway. As far as most of the sites is concerned, there are basically 2 dimensions in which speed data was collected. One is in space and one is in time. As far as the space is concerned, we spaced our speed data collection upstream from where the work zone is to get a context of how fast people were traveling before they even see the first sign for a work zone coming up. Then we collected speed somewhere within the work zone, usually at the very beginning of the work zone where people are entering into the work zone. And then we also collected data downstream from the work zone to see if there's some kind of spatial type of halo effect, to see if people are speeding right back up. But primarily our focus was really in wanting to have an understanding of what is going on within the work zone where there's active work, where there's usually some kind of space restriction, and where a lot of the conflicts that we are trying to prevent may be happening. As far as the temporal dimension is concerned, we looked at, we collected data when there was an intervention and when there's not. So in the case of targeted speed enforcement, because they might not be, we got the data from the state police or the various police agencies after they've actually conducted their speed enforcement. It's whenever they considered having an officers out there. And so we basically compare each day and the time periods in terms of when there was police enforcement happening and when there's not. When it's something that we were controlling the intervention, like when we stationed UTOs out there or when we had the signs out there, we compared weeks of basically the week before we had the intervention and then the week during when we had the intervention as well as the week after to see what kind of differences in terms of the travel speeds. So specifically about the device, we looked at different ways in which we can collect speed data. So you can imagine setting out tubes, some kind of radar. We ended up choosing a radar-based device called the iTones. There are many reasons why we chose this one. It's relatively easy to lay out. We didn't have to close traveling traffic to lay down tubes. They are relatively inconspicuous, especially in a work zone area where you already have these barrel-looking like things. And so we basically are able to work with WorkSafe and got these out there. The only thing that, because it's a radar device, travelers with any kind of radar detection do know that something is going on. So one of the sites that we had considered as part of the data collection was bridges closer into Burlington, and we had set them out at the Milton site, for example. And the project engineers there basically reported back that when we first had it out as a trial, that people were unexpectedly slowing down, and probably due to the heavy flow of traffic in the morning and the fact that some of them have some kind of radar detection device so that they were actually causing shock waves. And they were actually worried about crashes because people were slamming on their brakes. So because of that, we pulled them out of the more heavily traveled area, and then we went further north into St. Albans last year when we did that. So that's one of the interesting that we learned about this. About this system, it's really the cones itself. There's a battery in there, and there's a transmitter. And the data is basically collected as soon as it's turned on, and then every 2 minutes it gets sent to a satellite, and then the satellite sends it to a central data warehouse every 2 minutes. So in every 2 minutes, they have all the different readings which are recorded as basically count of speed reads within 5 mile per hour bins. So if a car was traveling at 48 miles per hour, it would fall into the bin of 45 to 50 miles per hour, and it would count as one of those per that 2 minute period if that was the only vehicle that was traveling within that bin. In addition, there's time and date stamps as well as the location of the device. These devices basically send out this cone of radar. It's similar to pointing a radar gun. And so you have to direct it in the direction of travel. Either the traffic coming towards you or away from you would read the same. But you've noticed that in all three of these cases here, we've positioned these cones in the median. So they are pointing at the direction of travel that we're interested in. So if we're looking at northbound, we're planning on only getting at northbound traffic. If you were to point it in a way that will actually, this line of vision includes both northbound and southbound, you can get speed data from both sides, which is the reason why this device, when you're using it in a 2-lane undivided road where you have traffic next to each other going in different directions, it is extremely difficult to position it so that you're only getting one direction of speeds. And because travel speeds, sometimes the speed limits are different on both sides or just the travel behavior is different, mixing that in really would not allow us to analyze with high confidence of the speeds in those kind of facilities. And so that's the reason why I'm focusing on the divided freeways for this presentation. So what we did after we collected the data over these periods of time is that we calculated 4 things. We looked at the mean speeds of the different periods. we looked at the standard deviation of those mean speeds to see how widespread people are traveling in terms of their speeds. And then we looked at the percent of vehicles that's traveling over the speed limit as it's stated, and then what we would call more extreme speeder, people who are traveling at least 5 miles over the speed limit. So there's a lot of people that kind of hovers around the speed limits, but these two are kind of indication of how much of the traveling public is going over what the speed limit is. And then given that data, we then did statistical comparisons between the different periods. So for when there's police targeted enforcement, we compare the times when there's with enforcement versus time when there's without. And then when we have the case of having an intervention that's there throughout a week, for example, we would look at the pre-intervention period versus the during the intervention period, and then again after, when it's during versus the post, to see if there's any statistical differences. So I'm just going to give you some examples of the data. I'm not going to show you all of the data, but these tables are kind of in the report. Basically, this is the data from 2012 when we were in Brattleboro in I-91, where there was state police doing targeted enforcement. So spatially, there were 3 of these icons collecting speed for the northbound and 3 for the southbound. 1 upstream from the work zone, 1 in the work zone, and 1 downstream. What I have highlighted are their speeds in the work zone itself. And so the speed limits there in both directions, 50 miles an hour. Without police enforcement, we're looking at around 53 miles per hour for the northbound and around 51.5 for the southbound. With police enforcement, it does go down and it is statistically different. But you can see that mean speeds are kind of difficult to tell how much the effects are, because this is based on hundreds of data points. So in order for hundreds of data points to go from 53 to 52.6, which doesn't seem like a lot, but it is still statistically different because of the large number of data that we have. These devices are 24/7. The periods that we're talking about, we usually compare only daytime periods when we expect there to be work going on, and we're trying to be consistent so that when we're comparing with and without police enforcement, that we're not comparing middle of the night when there might be more speeder, for example, versus when there is police enforcement during the day. So, but what this does show is that the police enforcement does have an effect. The mean speeds, however, is still higher than what the speed limit is going through those areas. So then this is an example of the other type of data that I'm talking about, which is showing how much the proportion of people that are actually going over the speed limit. So if we just look at this top, one table here, or one part is northbound and one part is southbound. If we only look at here, this row talks about how many, the proportion of people that are exceeding the speed limit. So without the police enforcement, about 3/4 of them, 72%-ish, is exceeding the speed limit. And then when there is police enforcement, it drops down to about 66. But when we're talking about exceeding by more than 5 miles per hour, it's lower at 40% without the speed enforcement, but it only drops down to about 35% with speed enforcement. So this is another view of the effectiveness of this particular intervention. And it doesn't vary that much across the different sites, but I just wanted to show another example. Because the data is collecting a little bit differently, the Brattleboro was with or without intervention. And in the case of the St. Albans, we're talking about before, during, and after. So we basically had UTOs. This was in the morning period, I believe, from 7 till noon. So we compared a week of weekdays, 7 till noon, having the UTOs out there, versus a week of 7 till noon without the UTO before, and a week of 7 to noon traffic period afterwards without the UTOs. And again, we have 3 northbounds and 3 southbounds, and 50 miles per hour speed limit. Before the UTOs, the mean speeds, it's pretty much around 50 at the northbound. During the UTO, it drops to about 47, and then it goes back up to 50 afterwards. It's a little bit different here. I believe the northbound is actually a little bit of an uphill, so they're going a little bit slower than the southbound. But they're dropping from 53 miles per hour before the intervention to 49 during, and then back up to around 53 after.
Brian, just
Yeah.
Back to Brattleboro, that with or without, you don't even have to go back to the data, with or without enforcement, that's just targeted enforcement, it's not UTOs plus targeted.
No,
That's
it was just targeted
I just
enforcement.
wanted to make sure it's clear. Okay,
Yep.
Thank you.
No problem. So, and then the last table I'm going to show you is for the same site in St. Albans with the UTOs, and this is showing the percentage of people who are exceeding the speed limit. The interesting thing is that if you're looking at the exceeding by 5 miles per hour, you know, we got about 23, almost a quarter of the people who were exceeding the speed limit on the northbound. This is the uphill side again. During the UTO, we dropped down to 4.5, so pretty good. And then it bounces back up again. The level of drop is similar for the southbound, but people were already going faster, and then it only drops down to around 11%. All of this basically were similar to the different results that we got for in St. Albans when we did the UTO by itself, and with the radar speed feedback signs were very similar in terms of how it functions. What I can show you is a summary of this in a kind of bar graph. The 4 sets here is Brattleboro and then the 3 St. Albans sites. The blue is basically without the intervention. The red is with the intervention. And then there are 2 directions for each freeway. So if you only look at the Brattleboro, and this line, all of the sites were at 50 miles per hour for the work zone speed limit. So if you look at the Brattleboro case, and what you see is that, and just remember that this axis is truncated, so it starts at 40, it doesn't start at 0, so the difference is a little bit exaggerated. But basically, in the Brattleboro case, or in each of the cases, there's an effect in terms of the intervention bringing down the speeds, and these are the mean speeds. But the Brattleboro case, you never really bring down the mean speed below the speed limit. In each of the other cases where we're looking at just the UTO, just the radar speed feedback sign, and the combination of the UTO and the radar speed feedback sign, they all are able to bring the mean speeds below the work zone speed limit to varying effect. And if you look at the percentage of traffic that's exceeding the speed limit, now I'm showing a little bit more. We have doubled the bars because for Brattleboro, for example, for each of the northbound, southbound, we're looking at exceeding just the speed limit or exceeding by more than 5 miles per hour. And this is from 0 to, this is a percent. So when we're looking at the Brattleboro case, for example, we're looking at, small decreases with the targeted police enforcement in terms of how they're able to bring these speeds down, the proportion of people who are speeding. This is UTO, and this is, I'm sorry, it got cut off here in the screen. It actually kind of shows what the interventions are. This is the police enforcement. This is just the UTO. This is just the radar speed feedback sign, and this is the combination of the UTO and the speed signs. What you can see is that these two, when you look at the numbers, they are relatively close in terms of their ability to bring it down, the proportion of speeders throughout a period of time. What was interesting was that if you combine the two, then combine the two of the UTO as well as the radar speed feedback signs, you get a compounding effect where you're bringing down even more. In some cases, close to 0% of people who are exceeding 5 miles per hour. So that's pretty good. And just to kind of remind you that these are over a long periods of time. So when you have a police enforcement, the state police says, oh, we're out there from noon till 4, for example. I fully don't expect there to be every single person traveling through from noon till 4 to see a police person there or see some kind of activities. So when they're targeted, they might be able to catch the speeders, and there might be a message that sends out, especially in the Brattleboro case, because they had 2 years worth of doing that. And in fact, Sergeant Roy, who was communicating with us and kind of helping us out, basically says, oh, this is our 2nd year. We fully don't expect a lot of speeders, but when you monitor the road 24 hours a day, you do find speeders because they know that the police are not out there 24 hours a day. And then for the UTOs and the speed signs, these are things that we are comparing only the time period when the interventions are out there. So if the UTO, we have them out there from 7 till noon, we're only comparing the periods of 7 till noon of the week before and then 7 till noon during. So we have pretty high confidence that almost every single person traveling through would have seen the blue lights during the intervention period. And the mean speeds as well as the percent exceeding speed limit really shows the entire population of travelers that would have passed through these work zones, and the workers would have been exposed to them and vice versa. So final conclusions, as far as in terms of the metrics that we use, which is basically the mean speeds and the proportion of people who are speeding, we found that targeted police enforcement was the least effective, and that's really specific to a period of time. They might have been very effective within a 5-minute period when people actually do see them or when there's specific activities, but as far as over a period of time is concerned and the total number of people traveling through, they're not as effective as the other ones. As far as the UTO and the radar speed feedback signs, they were similarly effective, but one was at $40 an hour, and this was at a weekly charge of hundreds. I think we got something like...
Yeah, they run between 1,000 and 1,200 a month.
Yeah, so we're depending on the length and how many we had. So there's definitely a cost difference, but we did note that there was a definite compounding effect when you use both the UTO and the RSFS in terms of bringing down really close to 0% of people who are exceeding the speed limit by more than 5 miles per hour. So I think what we can get from this is that as far as what we've looked at, these two worked out really well, but I think it really does depend on the situation. I think their usefulness in terms of spreading out your resources and say, at the times when you're doing certain types of work where you're interacting with the traffic a little bit more, when you're moving the barriers, or when you're doing things that are maybe a little bit more intensive, that you might want to have more than one device out there or more than one intervention out there. And then having the police enforcement, it's a little bit tricky because I think the Brattleboro case, you can argue that people are used to the fact that they know that police are going to be out there, but they may also be used to the fact that they catch on to when the police may or may not be out there. So I think there's an element of surprise when you're talking about police enforcement and when you look at the literature of what other people have done across the country. Consistency, and you have to balance that with that level of surprise to really make the police enforcement work. So I think the main takeaway is that I think between these three, you may be able to cost effectively monitor the speed of a site with the speed signs and maybe some combination with the UTOs when there's active work out there. And then if you want to throw in some elements of surprise, especially say during long weekends when you are doing work as well, you're expecting a lot of people, then you might want to have other extra types of interventions out there. So I'm basically done here, and I'm ready for any. Oh, actually, before we do that, I do want to acknowledge VTrans for the funding that was received, and there was some match as well from the USDOT. My research team, as well as the great people in the technical advisory committee. There's actually a whole long list of project managers and resident engineers who've helped out with a lot of the different projects, and I like to acknowledge them here, and they're also acknowledged in the report for all of their help. So, question, George?
With the difference between the targeted law enforcement and the UTL, I mean, I'm wondering if it's the color of the car, because I mean the state police is a green car,
Sure.
and typically the UTL is
a white car,
white county cars. So I wonder if that made a difference.
I think. Just anecdotally, I don't know for sure, anecdotally, talking to people who are not doing research in this area, they say, oh yeah, I noticed that green cars are the one that will chase after you, and then the white.
Right.
So I don't have a good way of actually knowing what the general public knows, but anecdotally, there seems to be some kind of perception, or at least guessing game. I think people like to know that kind of things. But I think it also has to do, if that is true, then you would expect the UTOs to be less effective than the green cars that are used.
Right. Well, what I was wondering is maybe the green cars is some camouflage into the environment, whereas the white cars are like right there.
Yeah, I don't know. That's a good theory. Any other questions? Yeah, Rich.
Couple. Pull them up here.
Sure.
At the beginning, you offered where some history or statistics nationally on crashes and fatalities in work zones.
Mm-hmm.
And then when you showed your map of the different areas that you started to collect data, then you focus more on the interstate corridors and freeways. I'm just curious, out of the crash data and fatality data nationwide, where are more of the fatalities? Are they on the interstate corridors, or is there any indication of where they are more than others?
That's a really good question. I don't know off the top of my head, but what I do know is that we are not really equipped to, and I mean we as in our data in this country is not really equipped to tell us about that. So I could find out the whole numbers in terms of how many are happening in each of those areas. But those numbers are only meaningful if you also know the proportion of construction sites in the 2-lane versus the divided freeway, as well as the amount of exposure. So if we combine all three of those, then we may be able to do that. I think I have seen literature from certain areas, certain states and certain areas within states where they might have all three of them, but I actually don't know if I can answer that for the country. My impression is that as far as the whole numbers are concerned, it's more for the 2-lane roads, but I actually don't know that for sure, so I would need to kind of verify that, but that's my recollection.
And then a couple real what-ifs, or
Sure.
maybe way out there, but one thing on the radar, it was interesting that you had to relocate because of people stopping with their radar detectors. I recall 15 years ago there was an initiative to attach similar radar guns on the back end of snowplows so that truck drivers and others that were approaching the snowplow would, there's something up ahead, I'm going to slow down.
Mm-hmm.
I didn't know if other states had dabbled with, hey, let's put out phantom detectors along the corridor, for that matter, or in areas where we want people to slow down and actually take them out a little bit to say, I don't know what it is, but I'm going to slow down.
Yeah.
Do it in a way that it isn't an additional safety concern.
Mm-hmm.
Have others heard of similar strategies at all?
I think we have radar drones on all of our port and transponder systems.
Into this, the speed feedback signs, I'm assuming with the radar as well.
Yes, yes.
We used to run them on our striping trucks, on the back of our striping trucks for that very reason.
Yeah.
So, food for thought and maybe future research, I'll throw that out to everyone here.
Yeah, when the project engineer mentioned that, it was, we did look into a little bit of the literature. It's tricky because I agree with the engineer's decision to not have it there, because when you have a situation like the morning peak hour and you do have heavy flow and the traffic flow is unstable to begin with when you're at a certain level. And so if you have these intermittent vehicles with the radar detector and they're slamming on their brakes, that might be potentially more of a hazard than anything else. That's consistent with what we quickly did a literature search of what other people have found in different areas. So we were not as worried about that in the St. Albans case because the traffic was sparse enough throughout basically all the 24 hours a day, 7 days a week. And when we actually look at the data itself, there's not really a good way for us to figure out if there is a proportion of population or to even estimate that. And there's not a good way for other people to really know how many people out there will have that. And there's theories and some evidence that the people who have it are the ones who are speeding the most anyway. So if those are the ones slowing down, then you're probably doing something good. And so I think it may be worth looking after, but it's kind of just unknown what the potential benefits would be.
And I would put it in the context beyond just work zones. It may be
Yeah.
a corridor management strategy when it comes to highway safety and speeds.
Sure.
And then the other one was, we're talking all about driver behavior here.
Mhm.
And interesting, I was looking at the data when you carved it into averages.
Oh, sure.
And when you look at human behavior when it comes to so many different things, from
Mhm.
recycling to, think globally, act locally, all these different phrases that people, but sometimes mindsets are that way.
Mm-hmm.
And if we were to post the average speed for the day through a work zone, I'm just curious, it's just a what if, what would the drivers as an individual think about playing a role in the whole?
Sure.
Some might play with it to drive I don't know, it's just a what if.
Yeah.
Posted the average.
I think that might be interesting. We found a whole list of what people might call novel ideas, having different types of messages. I haven't seen one like that, but I think that might be a good one. There are other ones that says, with the speed, with a variable message sign and a picture of a couple of kids that says, my daddy, mommy are working here. Or having, I meant to actually include this. I saw this one in Taiwan. Basically a car battery hooked up to this scarecrow-looking thing with the arms going like this as a electric flagger, as a way of catching attention. Now, there's, I think different ways in which we can look at these different interventions. You kind of have to look at, well, how much of it would actually distract versus being ineffective. But the one that you're talking about, if it's through a community, small communities like ours, and there's a concerted effort to say, oh, let's all slow down for these people, it may become a competitive thing,
Brian, in terms of, a lot of the driver for this particular research project was how do we most effectively deploy our resources? And that's, I think this has kind of led us in the direction, or at least given us some really good food for thought, and it's certainly on the interstate system. We spend also a lot of money on those two-lane railroads in
Yep.
terms of speed management and work zones, and I understand the reasons why the technology we tried here may or may not have worked.
Yep.
And we don't have to get into it today necessarily,
Sure.
if you haven't, but thoughts on how we may take a project like this and take it to that next level on the two-lane roads? And I know there's been discussions about, you know, we're on the 1,000 ADT road,
Yeah.
you know, with the paving project, and we're spending, you know, $100,000 on UTOs, how effective are they? You know, so do you have thoughts on how we could modify the program you just used here to be more effective on those two-lane roads?
Sure. I would just say very quickly that the Richmond project and the Addison New Haven projects are the two where we were able to collect data on two-lane roads. The Richmond one was targeted enforcement by the Richmond police. And it wasn't VTrans initiated, it wasn't us that initiated, but when we were collecting data and we were about to put out an intervention, we realized that, hey, wait a minute, the police are out there and they're actually acting as, they were, you know, using that opportunity to catch speeders. And that was very interesting because we actually, in addition to the speed data that we collected with the icons, we also mounted a camera to basically validate the information that we got from the icons. We got pretty good, what we were validating was the number of vehicles, so the number of vehicles that would have been caught by the icon and the number of vehicles that were visually seen in the video. And so we got pretty good at kind of maneuvering the icon so that it was able to catch the direction that we want. We realized that you could use the icons, especially around bends, where you can basically focus it on a part of a curve where you would only have one direction of traffic. What we did find was that the police enforcement did have a minimal effect, not too different than the interstate case. And then the Addison one, the only thing that was there was really flaggers, and it was a two-lane road that was being repaved, and places where it was being repaved, you know, when there was not the top smooth surface on, people were going way below the speed limit just because of the amount of debris that was coming up. So we knew that that wasn't really a problem. We had the cones out there kind of looking at the speeds. And it was, the average and the proportion of people speeding was way below what the speed limit was. It's when the top layer was applied in one portion and you're still working on the other ones where you do end up seeing speeders. And in those cases, when you are having at least one lane close of a two-lane road and you have flaggers that are basically stopping people, it's a matter of giving the drivers enough warning so that they can actually stop, because during the work zone itself where the paving is going on or where the lanes are closed, when there's a one-lane situation, people are going way below the speed and they have to stop anyway half of the time. So I think, you know, in terms of being visible and kind of serving the people who are actually stopping the vehicles, because once most of the people who are within that zone where they're actually stopped, then they are actually, you know, not going that fast. And I do think that there are different, you know, stemming from this, I think you can go in different directions in terms of different things that you can try. And I think if we can find, one of the problems with using the icons is that because it's still relatively flexible in terms of moving, but if it's in Brattleboro, for example, and at first we had a site, what was the Highway 4 near Fairhaven. So that one was a moving job that they were moving every single day. And you know, at first we thought, oh, it wouldn't be that difficult. And the resident engineer, I think it was Sandy, she was so nice in terms of saying, oh, I'll help you guys move this. But it very soon became apparent that it was just not feasible for projects that was constantly moving for us to test the different interventions. I think if you have a case where you have a static project like the Richmond Bridge case, where the project itself doesn't move, but then you can basically hold everything else pretty much constant and try different things over a certain period of time, then you might be able to better get definitive answers. What we did find in those cases too, the data was very interesting in terms of the distributions of speeds. Nighttime, we would see, in the Richmond case, people going 75, 80 miles. And it's not unusual every single day that we had those records for that to be going on. But that's, that's not when the work zone is happening, but that's a different safety issue in terms of people traveling at night.
Thank you.
So I'm happy to answer other questions if you think of them after this by email. And we have the PDF of the reports, and I think the final one will be finalized soon by George, and then that will be available, and then this video will also be made available. But like I said before, if there's a need for me to come down for another conversation, I'd be more than happy to do that.
Good work.
Okay.
Very good.
Thank you very much.
Thank you.